This is the 4.5 video for our notes, which was over scatter plots and lines of fit. So a lot of this lesson today was actually a review over material that you are hopefully familiar with from 8th grade, which is reading a scatter plot and kind of talking about correlation and line of best fit. So we reviewed at the beginning of our lesson today that a scatter plot is just a graph that shows a relationship between two sets of data. So we are focusing on data that tends to follow a linear type relationship, and that's what's going to allow us to draw a line of best fit. So here we reviewed just reading a scatter plot in order to answer questions. So the first thing that this tells us is that this scatter plot actually is showing the weight in pounds of a baby over time. So the first thing that we talked about was the actual word problem of the part of this, and we talked about, that as a baby increases in age by month, then its weight would also hopefully increase. So if as x increases, y increases, that's what's going to cause our data to slope up. And that is called having a positive correlation. And I related this to our slope because remember, a positive slope with linear relationships, the slope or the line slopes up from left to right. Okay? So we also talked about this word correlation, and I told you correlation, that's just that relationship between the two sets of data. So if you look at problem A, it says, what is the weight of the baby when the baby is 4 months old? So what you should notice is that the age in months is across your x-axis. So what you would want to do is go to where x is 4, because it asks for when it's 4 months old. Then you're going to follow that up to the line or up to your data points, and then you're going to go over to your y-axis and see where that point was. And that occurred at 14 pounds. So we would expect a baby that's 4 months old to weigh about 14 pounds. Okay? Then if we look at B, it says, what is the age of the baby when the baby weighs 17.2 pounds? So you're going to have to approximate, but that would be somewhere in between 16 and 18. So if I go over from my y-axis, because that's where your weight in pounds is, and then I go down to my x-axis, I see that in this set of data, that would be when the baby was 8 months old. Okay? So for this particular data, because it is so linear, it is almost in a straight line, we actually didn't have to draw a trend line. But if we were to draw a line of best fit, remember, we want to try to have an equal number of points above and below our line, and then we use that line to make predictions and answer questions like the ones they've given us. We were lucky here because there were actual data points that fell in the places that they were asking us about. So if you look at C, it asks what tends to happen to the weight of the baby as the age increases, and we said here that that weight also increases. And that's what caused that positive correlation. Okay? So I've already mentioned correlation several times, and remember, another word for correlation is trend. I use those words sometimes interchangeably, and what you're doing is you're looking at your data and you're looking to see if there is a relationship or if you're noticing a pattern or a trend in your data. Okay? So for these next 4 questions, it asks you to tell whether x and y show a positive, negative, or no correlation. If you look at problem 2, you should notice that our data tends to slope up from left to right. So as x is increasing, so is y. That is called a positive correlation. Just like with slope, if it's sloping up from left to right, it's positive. So if you look at number 5, it also shows that same positive correlation. So notice that these scatter plots are not quite as linear as that first example, but they still show a trend in the data. If you look at number 3, the points tend to slope in a downward, so that's as x is increasing, y is decreasing. And that's called a negative trend. Just like with slope, if it slopes down from left to right, that's negative. For number 4, if you look at the points, you notice that there is a very wide spread on your data, and the points are just kind of scattered equally all across the graph. So this has no correlation. When you're given an actual graph that you can look at, finding correlation should be fairly easy because you can actually see that trend in the data. But whenever we're looking at word problems or scenarios, make sure you're paying attention to those finer details and using kind of your common sense to see as one thing increases is the other, because if it is, that's a positive correlation. If as one thing increases, the other decreases, that would be a negative correlation. But if the two things are unrelated, that's what's going to cause no correlation. For this last problem, this was where it started kind of easing you into that algebra part of this. The first 2 sections were review, hopefully from 8th grade. So let's look at number 6. It says the table shows the depth, y, in centimeters of water filling a bathtub after X minutes. Okay, so I notice that I have time, which is my independent variable, or X, and it's increasing in increments of 2. Then I have my depth in centimeters, which is our dependent variable, and it is increasing, but it's not at a constant rate. So that's what's causing this to actually create a scatter plot. Now in class, we actually spent some time reviewing how to graph our data. We labeled our X and Y axis, and we picked our an appropriate scale, and we graphed so that you guys could look at it. Tonight, I'm not going to do that on my screen. If you're having any issues with graphing, please come in and talk to me and I'll help you. But I want to really focus on writing an equation that models the depth of the water as a function of time. So writing an equation, that's actually writing an equation for that line of best fit. Now this set of data, they were really nice to us because notice right here, they gave me my y-intercept. 0, 6 is where this graph is going to cross the y-axis. So that's telling me that I should be writing my equation in slope-intercept form because they gave me b. They gave me the y-intercept. So remember, in slope-intercept form, that's y equals m, which that's our slope, which we still have to calculate, times x plus b, which in this case b was 6 because that's my y-intercept. So the only thing left to do is to calculate our slope. So my suggestion was to choose a point towards the beginning of your data and towards the end of your data, just to get a nice spread and make sure that our slope is as accurate as possible. So I had you guys label x1, y1, and x2, y2. Remember, we're doing that because in our slope formula, we do y2, which in this case is 20, minus y1, which in this case is 8, over x2, which is 10, minus x1, which is 2. 20 minus 8 is 12, 10 minus 2 is 8. So we were left with this fraction. However, we are talking about depth in centimeters after X minutes. So we're talking about a measurement in a real world scenario. So I went ahead and divided and found out that my slope is actually 1.5. And that's what I'm putting into my equation for m, is 1.5. So I now have my equation, which is y equals 1.5x plus 6. That's going to be the equation that models this data as closely as possible. Okay? So then we talked a little bit about interpreting the slope and y-intercept of the line of fit. So I was a little surprised that several of you weren't really sure what the word interpret meant. So when you're interpreting, what you're doing is you're explaining what the what the slope and y-intercept mean in context of this particular situation. So my y-intercept is 6. So if you look back at your table, it will help you. So this says when the time was 0, the depth in centimeters was 6. So what does that mean? Well, what that means is that there was 6 centimeters of water in the tub to start with. Okay? Remember, back when we first started our linear stuff, we talked about that the y-intercept was usually a starting amount or an initial value. Okay, so this y-intercept is that there's 6 centimeters of water in the tub to start. Now remember, your slope or your rate of change represents how much your function is changing over time, in this case, because x was time. So for this one, we know that the water is increasing by 1.5 centimeters per minute. Okay? I know that it's increasing because my slope is positive. So the tub is filling at a rate of 1.5 centimeters per minute. Okay, so that closes our lesson for today. It was very short. It was our first day back from break. Tomorrow we will be working on line of fit and linear regression. You guys have a great night.